Lesson 8-4 in a nutshell. I'm calling it the shortcut lesson because here's the whole thing. If you are given a plus b quantity squared, the answer is always going to fit this pattern. If you are given the product of a difference and a sum, the answer is always going to fit that pattern. Now, let's work through some of the details. This is problem 1. What's a simpler form of this product? Well, x plus 8 squared fits that pattern that I showed you before. If you multiply it out, you will end up with x squared plus 2 times x times 8 plus 8 squared, which works out to be this. Same thing if you've got a minus inside the parentheses. You end up with this term squared, 2m squared, minus 2 times this term and that term, plus that term squared. Oh, look at that, they forgot. That should have a 3 squared, and it should be negative. Crazy. I think I'm just going to fix that in the book. This is the teacher book. Am I allowed to write in the teacher book? I guess so. Alright, that is a 3 squared. And it really doesn't matter. I mean, this should be a minus sign because that's a minus 3. But either way, your answer is going to be 9 because 3 squared is 9 and negative 3 squared is 9. So when you simplify it, you end up with this. Got it, number 1. I worked through for you so you could see a couple more examples. Hang on, let me switch back to my notebook. Okay, so given n minus 7 quantity squared, and I just wrote it out twice, it means you're going to square the first term. It means you're going to have 2 times the inner terms, and it means you need to square the last term. I figured it out by FOIL here to show you how the pattern works if you do it the other way. And your answer fits into that pattern. A squared minus, in this case, because this is negative, 2 times those 2 terms, and b squared. The reason I wrote it out this way is to show you, that's why this is a shortcut. If you do not memorize this and remember that that's how it always works out, you will still get the right answer if you just do it the way you learned in the last section. This is just a shortcut. It's not anything to worry you about. I'm never going to say, solve it this way for a test question. I might ask you what the pattern is for a bonus question, though. Then, oh right, there is a letter B for got it, number 1, which was 2x plus 9 squared. So I did the same thing again. I FOILed it out so that you could see that either way we fit this pattern. A squared, which is 4x squared, plus 2 times this term and that term, plus that term squared. Let's move on to the other pattern. Okay, we're skipping problem 2 and problem 3 for the moment because I want to zoom ahead to this product of a sum and a difference. What's a simpler form of this plus this? Well, isn't this the same thing? Plus or minus the same thing? And it's got to be 1 plus and 1 minus for this pattern to work. And it looks like they're going to give you every step. So here's the original problem. Here they are identifying, according to the formula they gave you, this first term is the a term. In this case, it's x cubed. This term is the b term. In this case, it is 8. And then they're showing you how it fits into the pattern, or how the answer works. So our rule is the a term squared minus, because we've got a minus sign here, the b term squared, which gives you x to the 6th minus 54. Hang on, let's go back to my notebook. So this has got it number 4, problem A, and again what I did was I FOILed it out so that you can see how it would work if you did it that way. X squared minus 9x plus 9x minus 81, which gives you that term squared minus that term squared. Letter B, and again I did it out the long way. You end up again with first term squared minus the second term squared. And these problems where you're multiplying one sum and one difference, your answer is always going to be minus first term squared minus the second term squared. There's one more. So they tried to get tricky by, making this look more complicated, but we've still got product of a sum and a difference. So that means first term squared minus the second term squared. And if you don't remember that shortcut, then FOIL it out and do it that way. Okay, problem 3 has a potentially very helpful idea here. You can use these patterns that you just learned to help improve your mental math. For example, given the difficult looking problem, what is 39 squared? Well, 39 squared happens to be the same thing as 40 minus 1, quantity squared. And you just learned that there's a pattern for squared binomials like this. So the pattern is 40 squared minus 2 times 40 times that plus 1 squared. And again, geez, I guess they're following their rule because this is always going to be positive. But this is a negative 1 here. Really, it should be negative 1 squared. And then 40 squared is 1600. That's 80. That's 1,521. I had to laugh after giving you such a lovely example for problem 3, because 39 is so close to 40 and that all works out so well. They gave you a really ugly example in the Got It. Anyway, 85 squared works out to 80 plus 5, quantity squared. You could probably also have done 90 minus 5, quantity squared. Either way, it's about the same amount of challenge. So this is going to work out to be the first term squared plus 2 times that, plus the last term squared. And then that works out to 7,225. I like doing this way much better than what I normally would have done, which would be writing out 85 times 85 and doing it that way. And this is much more impressive than needing a calculator. Similarly, with problem 5, you can use our other pattern. If you have a problem like 64 times 56, and you happen to notice that this works out to be the product of a sum and a difference because this is 60 plus 4 and that is 60 minus 4, then you can solve this practically in your head, because we know the pattern. 60 plus 4 times 60 minus 4 is going to be the same as this squared minus that squared. 60 squared minus 4 squared, which gives us 3,584. Let's take a look at Got It number 5. Okay, should look something like this. 52 times 48 is the same thing as 50 plus 2 times 50 minus 2. So 50 squared minus 2 squared gives us 2,496. And your next work to do is on page 495. Do all of 9 through 16. On page 496, just do the evens from 20 through 48. And all of these will work using the shortcuts you learned in this lesson or using any of the methods you used in the lesson before. Either way you do it, you'll get to the right answer.